Hello, my name is Nick Miletich with Managecore, and today I'll be discussing an SAP HANA migration to the Google Cloud Platform in 12 weeks, lessons from a recent go-live project. In today's webinar, I'll be discussing a brief overview of Managecore, followed by migrating SAP to the Google Cloud Platform, including requirements and considerations when migrating to GCP. I'll also be reviewing strategies to accelerate your GCP migration, and finally discussing a recent project in where Managecore migrated an SAP client to GCP. First, a brief overview on Managecore. Managecore is a certified SAP partner and the leading provider of SAP technical managed services. Utilizing our highly skilled engineers and industry-leading technology, we're able to provide intelligent solutions for the enterprise customer. Managecore is also a recognized leader in SAP HANA transformations, cloud solutions, and basis managed services. At Managecore, we provide unparalleled expertise. Not only are we an SAP certified partner, we are also a Google certified partner and reseller. Our tenured staff is certified in both SAP solutions and Google solutions. Now to talk about migrating to the Google Cloud Platform. Migrating to GCP involves a proven methodology. With Managecore, you're almost guaranteed success. It all starts with the planning phase. In this planning phase, you should take into consideration the size of your current environment, the performance of your environment, and also your data center needs. Depending on what you're running today, you may need more or less hardware than you have currently. This should all be reviewed and determined in the scoping phase. You should also determine your methodology for migration, whether you're going to use a tool set or standard SAP tools. You need to understand what is the best approach. Once that is realized, we move into the blueprint phase. In this phase, we're going to deploy what was determined in the planning phase and also start implementing the sandbox environment. If you do not currently have a sandbox environment, we recommend deploying either a copy of quality or production to try the migration testing out. In this phase, we're going to vet out all the key areas in your environment that require additional configuration, document them, and get them ready for your real environment in dev, queue, and prod. Once the blueprint phase is complete, we move into the dev phase and work through quality and production, finally getting into the support phase with about 2 to 4 weeks of hypercare and then into steady state support. In these different phases between dev and quality and prod, we recommend doing them in waves depending on how many SAP products you have. Generally, as an example, if you had VW and ECC and PI, we recommend moving all those environments in those respective phases. So as an example, in your development phase, you move development PI, BW, and ECC at the same time, followed by quality, followed by prod. Now I'm going to discuss SAP HANA requirements and considerations when you migrate to the cloud. SAP and GCP both provide great documentation on what is and isn't supported, along with best practices when moving into GCP. There are specific notes that you should read from SAP to detail exactly what is supported, right down to the version of SAP, the products from SAP, the database platforms, OS platforms, and even its types in GCP. Into that, GCP provides great design and architecture diagrams to get you started on figuring out how you want to deploy SAP within GCP. Now, digging a little further into this, please understand that only certain GCP products are supported, in addition to certain SAP products being supported within GCP. So not all combinations can be deployed. Starting with the SAP note titled SAP Applications on Google Cloud Platform Supported Products and Google VM Types. This note will tell you exactly what combinations of OS, database, and SAP platform are supported in GCP and how you can go about deploying them. Please look at this note frequently as it changes, but this would be the note that you go to start determining how to deploy SAP in GCP. Some key takeaways from this note include both ABAP and Java systems are supported, And NetWeaver 7.0 or higher is supported. So products like 460 and so on are not supported within GCP. It also discusses all the GCE instances and their equivalent SAPS ratings. So as you determine how much horsepower your current hardware has and that you require based on your business needs, you can convert that to SAPS ratings and understand that what instance type you deploy in GCP will match that hardware type. And I'll get into that in the next slide a little bit more. Also understand that only certain OS and database platforms are supported. So as an example, DB2, SQL Server, ASE, MaxDB, and HANA are supported databases, and SUSE, Red Hat, and Windows are supported OS platforms. Databases such as Oracle and platforms such as AIX are not supported within GCP. If you're converting to HANA, you also want to take into consideration the certified hardware list that SAP provides. So looking into the different instance types that SAP provides, there are certain instances that GCP and SAP have certified on standard NetWeaver stacks and HANA databases. The table on your left demonstrates all the instance types that are allowed to be run and have SAP installed on them. Note that these are not all the instance types available within GCP, and these are the only certified products that you can select. The table on the right shows the certified HANA appliances that are allowed to run HANA in GCP. Note that you see redundant instance types such as N1 HiMem32. There are 2 entries in there. Both are the same size and the same instance type. However, SAP is showing you that you can run B1 or lab OLTP databases on this type of instance, such as S4 and BW on HANA. Note that once you get to other instance types, such as the first one, which is the M208, that is 6 terabytes, and only OLTP is allowed to run on that. So you're not going to run Business One, and you're not going to run BW as an example. Now understand too that unique to GCP, you can have custom instance types, meaning I can specify the exact amount of CPU and memory I'd like to run SAP on. Although this is not supported for HANA, it is supported for the NetWeaver stack. Now, you do have to reference that note as there's certain ratios that are required in order for you to run that in a supported fashion. However, you do have the capability of running custom images within SAP, within GCP, and still be certified with SAP. Now I want to talk a little bit about common GCP terminology. So as we go to this presentation, and as you're looking into GCP, certain naming conventions and certain products will have to be understood, and this kind of gives you an overview of the most popular ones that you would see and use when deploying SAP in GCP. The first one is GCE, or Google Compute Engine. This is what's considered the server, or the instance type, and this is the memory and compute that you'd be running your environment on. Then we have persistent disk. This is what you would consider your traditional SAN storage. So this is block level storage and is used for high performing environments. There are different types of persistent disk within GCP, so you have to choose wisely. They all have different varying speeds and performance metrics, along with different technologies around them. One specific one is SSD, as an example, can be local within that zone, or they have regional SSD, which means it spans the entire region. They also have standard HDD disk and different types of technologies within that framework as well. So you need to understand and choose your disk wisely based on your needs. Then we move on to cloud storage. This is your inexpensive data storage. It's your object-based storage and what's used most commonly for backups. So as you do backups to possibly persistent disk, you can then take those backups, move them to cloud storage, and keep them there for your retention period, on average 30 days. Now I'll go into region and zones in the next slide. However, I just want to mention what they are briefly. A region is a geographical area that's comprised of multiple zones, and a zone is what we consider a data center within that region. And finally, a VPC, which is a virtual cloud. This is your data center, if you will. Now, these environments within there is what you configure initially, and this VPC will hold your subnets. It'll have your IP address ranges, but it'll also hold your storage, your compute, and anything you deploy within GCP will be under that VPC. Now to talk about a little about GCP regions and zones. So GCP uses the standard public cloud region and architecture when discussing where to place your infrastructure. So a region is a geographical location and is tied generally to a specific area of the world. So as an example here, one region is US West 1, which is Oregon, if you see on the map here, and that is what we would consider a region. Now, if you see that map to your left, you will see the number 3 in Oregon. That is the zone. So what this map is telling you is that a zone in this region, there are 3 of them total for Oregon or US West 1. A zone is what you would consider a physical data center. So those are 3 separate and disparate locations within US West 1 or Oregon that you can put your environment in. Now, you have to understand as you're deploying SAP and decide what your environment, you have to have certain considerations around which specific region you're going to place your environment in. Generally, you want one with the lowest latency back to your main user base. So if you're located on the West Coast and maybe Northern West Coast, you'd select Oregon or US West 1 as your region of choice. Then from there, you would select the DR region. Now you want to make sure that in your DR region, you may have specific geographical requirements, such as they have to be so many miles apart, and you'd select a region accordingly. So for example here, maybe you select US East 1. So you can put these environments within different regions, and within these different regions, you select which zone you would like it in. And I'll get into HA and DR topologies in another slide, but the other part you want to take into consideration is the amount of resources that GCP has in each region. So in each region, you have to determine whether or not the product you want from GCP is in fact available within that region. So GCP generally has all products in all regions. However, there are certain specific products that you just have to be cognizant about and make sure that if you have certain GCP products, you are in a region that actually offers those products. Now to discuss network design and technology. The most common network technology used to connect to GCP is a cloud VPN. This is your traditional IPsec tunnel and is the quickest way to make a connection back to GCP. Now, although it does traverse the internet, an IPsec tunnel is secure, and within GCP, it allows you to do up to 1.5 gigs per tunnel. And unique to GCP, you can actually combine multiple tunnels to increase your bandwidth. So you can have aggregate VPN tunnels and spin up a multitude of them to increase the amount of throughput you have in the event that you need to transfer large files. So for example, if you're doing a migration and you needed greater bandwidth, you could configure multiple VPN tunnels, combine them together, and get the bandwidth you're looking for. The second most common network topology is going to be a partner interconnect. This product is actually a private connection between you and GCP, and it's always provided by a specific partner of your choice. So if you're working with a specific carrier, you can call them, ask them what offerings they have for GCP, and they'd be able to extend the GCP network into your data center or colo facility or headquarters just by traversing the partner's actual connection. And they'll make that connection between you and GCP. Now, this effectively extends your VPC and GCP to your headquarters, as an example. It is used when you don't have a direct connection to one of the Google backbones in a specific data center. It's generally the most popular private connection. Depending on the carrier, you'll have to ask each of your different carriers. However, there are options where you could extend, for example, MPLS circuits using this technology and your carrier's technology into GCP. So there are options. Again, it's highly carrier dependent, and those are the conversations that need to be started early with your carriers to make sure that by the time you go live, you have that partner interconnect in place and tested. At that time, generally cloud VPN solutions at go live are used as backup connections. Should your partner interconnect go down, you always have your VPN tunnel as a backup solution. The third but least popular solution is a dedicated interconnect. This connection is a direct connection to GCP. However, it's a connection that you have to tap into at a drop location at a data center that GCP supports and is actually located in. And that's generally pretty difficult for clients to do if they're not already located or don't have infrastructure in those type of environments. So that's why a partner interconnect is the next best solution, because it does allow you to drop directly into GCP by traversing a partner's already existing connectivity. All right, now I'm going to get into reference architecture of SAP within GCP. So let's start with your traditional SAP. If we were to deploy a standard ASCS, PAS type of environment with a database, and in this slide you see that it's HANA. This slide can be any database, but we'll use HANA as an example here. This is how you would deploy a traditional network stack. As you can see, the environment itself is in a private subnet, and then you have a public subnet for things like SAP router and jump servers. All this is within a zone, so a physical data center, and then that zone is within a specific region. So, we can use the example of US West 1, so in Oregon, and we're in one of the three zones in Oregon here, so all in one data center. And then there's a connection back to the premise environment, either using an interconnect or a VPN tunnel. As I mentioned some of the technology before, you see that we're using persistent disk to hold the standard volumes of SAP, such as SAP mount and things of that nature in the database itself. And then we use the same disk to hold backups. So we're going to take backups to this persistent disk and then move them to cloud storage for longer-term retention. And I'll get into backup topology in another slide here as we progress. There's also scale-out options, distributed options. Just as a traditional data center, you can distribute the PAS and the database and have a more robust solution, but this is a design that starts the framework of how to deploy SAP. Now I'll talk a little bit about high availability and disaster recovery, and we're going to start with the HANA database itself. So in this diagram, I'm going to discuss how we can provide HANDR within GCP for HANA. So as you can see here, we have two HANA databases, a primary and a secondary within a single region. So again, using the example US West 1, both of these zones are within US West 1, but these zones are actually different disparate locations. So in this example, I'm using one HANA database in one data center or zone. I have another HANA database in another data center or zone, physically disparate. I'm using HANA replication to keep them in sync, and then I'm using a clustering solution to provide that heartbeat monitoring and failover capability. In this case, generally we utilize SUSE HAE within the Google Cloud Platform. And in the event of one of these failovers, the secondary node would take over and fail over when the timing is appropriate back to the primary when it comes back online. Now for DR, we're doing the same thing, except we're going to a different and a different zone. So possibly do a US East one in one of their zones, disparately located across the country. And here, I'm using HANA replication to migrate the HANA database as well and have a hot standby there. So here we provide, and we're able to provide high availability and disaster recovery within GCP using HANA replication. Now this diagram depicts if you were to take one step further and have your SAP application highly available, you can do so in GCP. So in this example, I've split out the AFCS and the app servers, and I'm using a clustering solution, again, such as SUSE. And within that environment, I'm configuring it in a clustered environment, and now we're in one zone and one region. You can span multiple zones, so similar to what we did for HANA in the last slide, we can do that with these environments as well. And what that does, that separates your SAP environments within different physical data centers. So you have HA capabilities between different data centers. So in a traditional on-prem environment, you'd be doing this all within one single data center. The Google Cloud Platform allows you to do this between separate data centers. So very unique to the public cloud is I can actually do HA cross data center versus just maybe cross rack if I was doing this at a colo or on-premise. Now to talk a little bit about the GCP backups. So just as any other data center or on-prem environment that you would have, backups are required in GCP as well. Now there's two different types of backups we'll be talking about. One are the actual servers or instances that we need to do backups, and one is the actual database that we'll have to be backing up. So in this slide, I'm going to focus on just the instances themselves. So GCP provides the ability to take snapshots of your instances or servers and have them be backed up to cloud storage. So in this example, what GCP is providing is a snapshot of your existing environment, your server. It's a full snapshot, and then you do incrementals for your environment going forward. So you have that one golden image, and you continually do differentials. GCP offers the functionality to schedule these, so you can take that golden image, you can continually do incrementals at any frequency you'd like, let's say every hour, and those snapshots get put into cloud storage. And then you can have retention policies. GCP also allows you to schedule those retention policies in cloud storage to say, after 30 days, as an example, they would get deleted, and you'd only keep 30 days worth. All that functionality is built into the Google Cloud Platform. Now we'll focus on the HANA database itself. So there are a couple ways to back up a HANA database traditionally. One is to disk, and then using a job or a product, you can copy that off to traditional methods like a disk or tape, or you can use back-end technology. So that is an SAP product that allows you to integrate with backup tools seamlessly and migrate your data directly to tape and bypassing standard disk as an example. So in GCP, you can actually do it both ways. The first method is to actually take a backup to persistent disk, and then at a scheduled interval, you can move those backups to cloud storage and then purge that persistent disk and start over again. One unique thing to GCP, and it's a great technology, is GCP invested in the backend technology with SAP and has become certified and is the only public cloud certified to use backend. That means GCP has developed a way to take your backups using backend, bypassing persistent disk and going right to cloud storage. And that's what this graph depicts here. Basically, using backend technology from GCP, there's no longer the requirement for that persistent disk to sit there and you having to do basically 2 hops to get backups into some sort of storage mechanism for long-term retention. Backend and GCP will take it right to cloud storage. This saves you time, this saves you money, and this obviously saves you complexity because you're not making those 2 hops. So very unique feature to GCP. Okay, now we're going to dive into a 12-week SAP HANA migration within GCP. I'm going to discuss a few options when migrating your SAP environment into the Google Cloud Platform. You really have 2 main options. One are SAP standard migration tools, and the other are cloud migration tools. Both have their pros and cons, and it'll depend on your specific situation as to which one you would be using. So the first tool set are the SAP migration tools. This is your standard homogeneous or heterogeneous migrations, possibly using SUM or DMO or SWPM, those type of tool sets where you export the database, you move the database, export files over into GCP, and you resume the import process, and you create these systems from scratch. Now, there are pros and cons to this. If you are moving from an environment that may be a little older or that you're not sure what is on that OS, this may be a good option for you because you are installing new OSs in GCP. This gives you the opportunity to clean up whatever you feel like could be in your existing environment, and it's a brand new net install. There are caveats to this because you are moving data at a single time, so it's very sequential. You will have to load the tool, export it, copy the file over, and then continue importing it in general practice. So there is a very sequential process, and this may take some time, but it really depends on your use case. This is also heavily used in environments where the source system is not a supported platform in GCP. So for example, if you're running HPUX today and you want to move your environment to GCP, you may not be able to use cloud migration tools to perform that. And your only option would be SAP migration tools. Now, there are cloud migration tools out there as well that you can use and migrate your system in different fashions, right? These migration tools are generally installed on the source environment and have some sort of replication technology to migrate you into GCP. They can involve anything from copying the files over and syncing them in that environment and then firing them back up in GCP when they're all synced. GCP has a tool called Anthos Migrate that they offer for free to migrate into the Google Cloud Platform. That one works a little bit differently in the sense that you install it in your environment, and when you install it, within about 15 minutes, that system is up and running in Google. It spins up the server, it starts some of the replication, and you have a running system in that environment. Now you're probably thinking, how does that work? How can I replicate, if my system's 5 terabytes, how can I replicate all that in GCP within 15 minutes? Well, the secret is it doesn't replicate everything. It replicates the OS, it replicates the binaries, and then it replicates some of the database. The most heavily used parts of that database, after it does its analysis, it migrates into GCP. And then it'll sync for a period of 24 hours, a couple days, a couple weeks, depending on how large in your bandwidth and how much bandwidth you have will be dependent upon how long it takes to fully sync. But it is smart in the sense that it understands what heavily used tables you're hitting, and we'll migrate those first. Now, if during the process of migration, let's say it takes a week, and during that week you're hitting a few tables that it didn't feel was heavily hit, but now you're heavily hitting it, it will sync those, and those would take priority so that you can have better performance. And it does standard dedupe and compression so that you can transfer those files in a quicker fashion. So there is that tool set available as well that allows you to perform migrations fairly seamlessly. Now these tool sets, again, allow you to do a sync and replicate over, therefore bypassing the need to do or have to deal with bandwidth constraints, because as long as you plan the timing of it, you can have that replication occurring for even a few weeks until it catches up. Now, in addition to Anthos Migrate, there are other tool sets that are more traditional in nature that you install software on the source system and it will replicate the whole environment, and when it's fully synced, it'll start doing deltas and changes, and when you're ready to sync, you just shut SAP down, sync the remainder of it, and then fail over. So there's two different ways, in practice on how that can be, how a migration can happen. Now, obviously the benefits of a cloud migration tool is it's fast, it's seamless, and you can replicate within minutes. On the flip side, it is a bit more intrusive and generally requires, especially if you're running VMware, an OVA to be installed in the source environment, and you just may not have access to that, especially if you're in a hosted by a private cloud vendor that doesn't allow you access to their VMware infrastructure. It may be difficult to accomplish. So it depends on the tool set, depends on your situation, and that'll tell you and kind of drive which direction you should go. This slide depicts a few different data transfer options. As we discussed in the previous slide, you may have to do the SAP migration tool method or a public cloud, tool method. However, each one will vary based on your bandwidth as well. And this is something you need to take into consideration early on, because if you need more bandwidth and you have only the ability to do an SAP migration, you'll have to understand that, as an example, if you had 10 terabytes here, but you only had a 100 meg circuit, your 10 terabytes is going to take you 12 days to copy. And most SAP customers do not have 12 days to wait for that to copy. So in this example, if you had a 10 terabyte environment, you'd probably want at least a 1 gig pipe so you can get it within 30 hours of replicating and then still start the import. So that whole process could take 72 hours in this case if you're doing traditional, data transfer. But those are the type of things you have to take into consideration. If you're going to use a cloud tool, such as Anthos Migrate as an example, and you had 10 terabytes, you could still get away with, say, a 100 meg circuit. It would just take longer to replicate, 12 days, but you could start the replication a month ahead of time, and you'd be well within that 12-day range. So you migrate and you kick off the replication. It takes 12 days to sync, and when you're ready, you click a button and fail over. And that's what the beauty of the public cloud allows you to do, is use those type of technologies to migrate your environment and not really have the bottleneck of bandwidth. Now, for larger clients, again, you're getting into the tens of terabytes range. It may be also more beneficial to get a appliance. So Google offers a transfer appliance service, and what they would do is they ship you out a transfer appliance. You plug it into your network, copy the files, ship it back. Google plugs it in and ingests it within 48 hours, starts the copy, and you're good to go. Now, obviously, it takes a while to copy and ship and get from point A to point B, so keep that in mind as well as you're thinking of all your different options for migrating. Now I want to switch gears and give you an overview on a recent project Managecore did in moving a client running HANA into GCP. So a little background on the client. Recently, Managecore migrated FFF Enterprises into the Google Cloud platform. We had discussions with them, and their main challenge was that they had several production outages and service-related issues from their current vendor at the time, and they wanted also a platform that they could innovate on, and they felt like private cloud didn't give them those capabilities. So what Managecore did was we came in, we architected a plan and design and sat with the business and figured out, their direction and where they were at today and what they wanted to see and get out of their SAP environment. We came up with that migration plan, and as mentioned earlier on in this presentation, we started with that planning phase, then did a sandbox iteration and moved through the landscape. That sandbox iteration did uncover specific things in the environment, such as certain network shares, certain host names, load balancers that were required, vanity URLs. All of that was taken into account and vetted out in that initial sandbox run, and just cleaned up as we went through the process between dev and Q and prod. And then we migrated them using a tool set similar to Anthos Migrate that synced the environment. And what that allowed us to do is install this tool set within their environment. It's synced for a period of a few days, depending on the size of the environment, anywhere from 1 to 4 days. And at that point, once it was synced, it was doing deltas up until we were ready to migrate. The tool set did allow for a mock migration. So each iteration, we performed a mock migration, spun the servers up in GCP just to make sure the OSs were okay and that they would come up okay. And then once that mock was done, usually a couple days in advance, we'd prepare for the actual migration. Then, when it was time, we would schedule the migration, and each iteration of dev, Q, and prod roughly took anywhere between 4 and 8 hours at a time. So by the time we got to production, which was done on a Saturday, we started Saturday morning, and we're done by noon on Saturday, and everyone was in the environment, and everything was converted within a period of around 4 hours on that weekend. So very, very seamless. A lot of testing that was available to us that we could do in a platform like GCP, where we can't do in a private cloud platform or on-prem, as an example. The GCP platform allowed us to do that fairly quickly and spin up servers and subnets very quickly to accomplish this. Now, the client not only got an increase in reliability, but they got an increase in speed. Now, like for like, when we moved from a private cloud to a public cloud, some of their reports were operating at almost 7 times faster than their existing solution, all things being equal. We did not patch the environment. We did not upgrade them to higher systems, memory-wise in HANA, but they did see performance increases of up to 7 times. They also overcame that challenge associated with HA, right? In the public cloud, we designed it and architected it in such a way where uptime was taken into account right from the get-go. This allowed us to architect the solution that FFF was looking for all along. Now, with that peace of mind as well, it allowed this client to focus on innovation within their organization. Using all the GCP had to offer, such as possible BigQuery or any IoT or machine learning, they can now expand their portfolio and use that to innovate what they're doing versus just focusing on supporting their environment. So it really was the stepping stone to further their digital transformation and expand and really become a market leader in their industry. Well, thank you for attending today's webinar. I hope you found it beneficial. I know that there's a lot of interest in migrating SAP to public clouds, and the Google Cloud Platform is a very solid choice when looking at the different vendors, and the Google Cloud Platform also offers unique SAP-centric technologies that just aren't offered anywhere else. As a way to get started on your cloud journey, Managecore would like to offer today's webinar attendees a cloud simulator assessment that is powered by Google's Cloud Physics. And with this cloud simulator offering, you get answers to all your questions before making any commitments to deploy or migrate your critical SAP system into the cloud, such as allowing you to compare side-by-side cost and compatibility with GCP versus running on-prem. And this cloud simulator will actually help you get a better understanding of what it takes to right-size your GCP environment before you actually migrate. So it does all the calculations for you, and you can understand exactly what you're going to and what you're coming from a performance perspective. And as mentioned, this offer will be available to all of today's attendees, and a link will be provided via an email to sign up after this webinar. So you can also find a link to register on our homepage website, Managecore.com. Again, I hope everyone found this beneficial. If you have any questions, feel free to reach out to me directly. My phone number and email address are on this slide, and feel free to visit Managecore.com for more information. Thank you. Have a great day.